Hi, today we'll be working on some pointer examples again in C. I have my IDE open, I'm using C-line. So just, it'll be a character pointer, actually it'll be a string example, so let's just declare a character array here. Character array named A, and we'll just save it to, we'll point it to the string welcome. So if we have a character array named A, which points to the string welcome, then let's say the pointer P. Let's declare a pointer P here and set it to A. So I'll just have pointer P. Whoops, I didn't set that properly. So let's just say character pointer P points to A. There we go, and then we'll say here. So what's going to be the difference if we say pointer P plus plus? So what is that going to give us versus when we have it in brackets? Whoops. So if we have it in brackets, so pointer P plus plus like that. So what's going to be the difference? So let's see what the difference is. Let's just put a breakpoint there. Save it and run it in the debugger. So let's just see what the difference is between those two. Because the brackets can get confusing in pointers. Sometimes they can get confusing. So we have pointer P pointing to A. That means the pointer value P should point to the first index in the array, which is W in this case. So I believe this is how strings actually works in the back end. So they're byte arrays, right? Everything memory related is a byte array. So anyways, in this case, it's lower level programming. It's a lower level programming language. It does have some concepts that'll be related to C++ and C#.net. So a lot of this stuff is helpful though. So we have, once we execute this line, we'll see what we get. So we have pointer P, the pointer P value is pointing to E now. So that should be correct because we went from index 1 of the array, index 0 of the array, which was W. And now we're pointing to index 1 of the array, which is E. Because when we have plus plus, that means plus 1, of course, right? It means P equals to P plus 1, that's what it means. Or just P plus 1, whatever sounds easier for you. So in that case, when we're referencing the asterisk, which is a pointer, then we want the pointer value. So just remember, asterisk is pointer value. P is just what the pointer is pointing to. P is just what the pointer is pointing to. And the ampersand sign is the address of. So as you can see, P should be pointing to, is that A? Okay, so we have P pointing to the memory location 0x5E 843FF891, or is that 3 Fs? That's so small, the writing, I can't see it that well. And then we have, is that A? So, okay, yeah, so should be the same memory location. I'm just gonna stop that and re-debug it. Okay, so we have, that's P, okay, so that's POX, OX82855FFF, or FFAD. So if we step over, should it be the same? Sorry, P should be pointing to the same. Perhaps the index over shifted by 1 or whatever, how many bytes difference it is. Okay, so it's 60, the last digits. Step over 61. Okay, yeah, so it shifted over 1. Actually, you know what? One more time, just to, I can't copy that value, can I? Can I? Okay, I can. So we have that copied. Let's step over this one too. I should copy it. Copy that one. So we should have two of the exact same values. Memory locations, addresses. So now if we step over, what are the addresses now? Let me copy them. So we have OX252DDFFD3, so it's shifted by 1 because it's the next array index. So hopefully you guys see what's happening here. Copy, well, which one did I click? Copy, where the heck did it go? Okay, it's down here. Copy value and paste it there. Okay, so now we have OX252DDFF3D1, so it's the same thing. It shifted over by 1, so we can see what's happening here. When we reference star P++ without any brackets, it's just, originally star P is just pointing to index 0 of the array, which is W in this case since it's a string. So now if we comment out this line and uncomment this one, what do we get now? Let's put our breakpoint there, save it, and then re-debug it. Okay, so we have the same thing, of course. And if we step over, where do we go? Okay, so now we have pointer P pointing to Did I change something? No, I did not. Okay, so we have a garbage value now. So it looks like pointer P in brackets ++ shifts. It kind of goes to, seems like it goes to garbage, and the first array index got changed to garbage, so it's kind of confusing. But pretty much, I think what's happening here is that we have, instead of starting at index 0, it's like, okay, we'll take this whole thing. Actually, not even like, it's just like, okay, we'll take this whole thing. It's like this. Take this whole thing and plus that. So add 1 to that. So I'm pretty sure that's what's happening. And it pretty much just gave us garbage, because it doesn't really know what to give us in that case because we have nothing else. So I'm pretty sure that's what happened. So we'll move on to the next example. So we're gonna have a little bit more practice with that just to clear up some confusion. So we will have an int array here. Let's say we got an int array named A, and we'll set it up with those brackets. So we have 1, 2, 3, 4, 5. And it shows you, I don't know if you can see that, but, oh, excuse me. So we have index 0 is pointing to 1, 1 is pointing to 2. So index 0 is pointing to 1, index 1 is pointing to 2, index 2 is pointing to 3, index 3 is pointing to 4, index 4 is pointing to 5. Hopefully you guys can see that the IDE is like giving some hints. So now let's say we have an int pointer p. So int pointer p points to the address of a of index 0. We could have called this array. But that's okay, so we'll just have it like that. So we have a pointer p initialized to point to the address of a of array index 0. So p++ should give us the next index in the array. And what we want to clear up confusion is with the bracketed pointer p++. What's that going to give us? If we're setting the pointer, but actually this might be a little confusing because we're setting the pointer value to point to the address of the index. So p++ should just give us the address 2. But the pointer p is also holding the address, so let's see what we get here. So we have p++ pointer p++, and we have p plus equals to 2. So what that means is p equals to p plus 2. Some people might be new to seeing those, so we have, it's pretty common across a lot of languages, so we have p is equal, or p points to like this, p plus 2. No, that's wrong. P points to p plus 2, like that. P equals p plus 2, or p points to p plus 2. So if p is 0, then p is 0, right? So p equals to, what's p? So p equals to, then we put 0 here plus 2. Then that can continue on in a loop, but it's just happening once. And then now we have, let's just say the pointer. Some schools do teach C first instead of Java. Some schools teach Java first, then C. I feel like I'm one of the special schools that learn Java first, because I know at UBC, the University of British Columbia, which is like over here, people think it's a good school. It's honestly not that great. Like, well, some of the departments are good, but honestly the computer science department isn't that great. I've seen their program. Other schools in BC, like, I'm just gonna say other schools, like for example up north, more schools in northern British Columbia, they have some of their programs are a lot better. Also Simon Fraser University in British Columbia, in BC, like, if you don't know where BC is, it's in Canada. It's above Washington State in the States, United States. It's pretty much just over the border. Like, I'm like a half-an-hour drive from the border itself, so it's not far at all. Even less like that if you're really speeding. Like, we can get there in like 20 minutes if you're going fast. 20-25 minutes. Anyways, their program isn't that good either, and I think they start with C2. But yeah, most of their stuff is just like theory stuff. So I kind of got lucky where my school teaches us a full stack of languages. So it's like a lot more helpful than going into the programming field with like two languages like C and like something else. Like it's not that great. Anyways, I'm getting off topic here, so let's just say we have pointer P. The point is, C could be your first language, that's all I'm saying. So anyway, so we have pointer P++. So that's why I'm trying to simplify that. So we have pointer P++, and what is that going to give us again? So it's going to increment once up here, increment again here. And we have P++ is going to increment once up there. We could even increment it again after, so that's fine, so we'll just save it. Anyways, there are probably some university students in the States or in Canada listening to that, so hopefully you guys find that bit of information interesting. So now we have int a array pointing to this. So that should be fine, we'll skip that. So now we have the pointer value P pointing to the address of A of array index 0. So we want the pointer P. So the pointer P itself is pointing to, is giving us 1. Okay, so we have P pointing to the address. That's, I guess that's like automatic. So we're saying okay, well we want the pointer P to point to the address of array index 0. Okay, so there's no change here, so we have pointer P pointing to 1 because that's the pointer value. So it seems like if we have the ampersand there or not, it's going to give us the same thing. The pointer value still points to the pointer value. We can double check that by taking that off in 1 sec. So we have the pointer value P pointing to 1. And then we have P pointing to the address of the array. So same thing, P is always going to be default the address. Whether we, what's the word? I'm going blank. So it's, if you like initially declare, so if we have pointer P points to the address of, or if we just have pointer P pointing to something, then we say P points to the address of, not the pointer value, but just P. Usually a lot of codes do that, but I think that's happening in the background automatically. That is somehow set automatically, so P is always going to just point to the address of the array. Like automatically, whether you set it up explicitly or not. Sorry, so the word was explicitly that I was trying to look for. So we have, so then if we have P plus, what line are we on? Okay, with this one. So if we say P plus plus, then we should get the next address. Sorry, we got the next index. Yeah, so we got the next index. So it's just the same thing with whether we set this ampersand or not. Pointer, which kind of makes it good to know because we have pointer P. The pointer value P is pointing to the first array index, whether we want to set it explicitly or not. Whether we put the address symbol or not, the pointer value P can only hold the value. So then we have P automatically storing the address. It doesn't tell us the address of A, so that's okay. So if we have, so what's going to happen if we say, okay, well we want the whole pointer P, plus plus instead of, do we do pointer P plus plus? We said P plus plus. Okay, so there we go. So I skipped something for you guys, so my bad. So we will go back to this line here. P++. Okay, so what's P++? What's P pointing to? P is always going to point to the address, as we said. The memory location. So if we say P++, then that, what is that address? So let's copy that. Paste that. Okay, so we have, that's the address. So we say, okay, well we want P++. That was P right now, so I just copied P. Then we got, okay, so that totally makes sense because that incremented by 4. So in the last example, if you notice when we had the string, the character string, it incremented by 1 probably because each characters are 1 bytes or 1 bit, right? So this time it incremented by 4, I believe. That's because the int arrays are each int is 4 bytes, so each array from beside each other should be 4 bytes spaced out in memory. So this P++ incremented the address itself, so P storing the address, pointer P storing the value. Whether we get tricked with the address symbol or not, the pointer value P is always going to point to whatever the P address holds in the value. So whatever value is being stored at that address, that's only what pointer P can hold. So whether we get tricked with the ampersand, it's only going to store the pointer value. So if we want the pointer value if we just want the P++, then that's just going to be the address ++. So in an array, it's just going to move to the next index. Right, because it's going to move to the next index in the address form rather than give us 1 or 2. It's going to give us the address beside 0. So this one's index 0, right? See my mouse on line 12. That's index 0. And on line 13, that's index 1. So it's going to give us the next index over. And since they're 4 bytes spaced apart, because it's an int array, right? Then it's going to give us the next index over, which is going to add 4 bytes to the memory location, spaced over. So the next one should give us that +4, that +4, that +4, and so on to the end of the array. Okay, so now if we have the pointer value P++, and that's the whole thing rather than without brackets as we said last time. So what would we have? Right now for pointer P, we have 2. Pointer P, we had 2, now we have 3. P equals 2, so that should give us the what did I do? Whoops. Okay, so we have this, so the next one should give us, so this line should give us the address added. And now we have the pointer value P again pointing to 4. Sorry, now pointing to 4. Okay, so let's just back up here for a sec because I think we need to track all these variables while we're moving over. So where did we say this was? So we said that at P++. Why do we have so many? What is happening this time? It's glitching out. Might be glitching out. Okay, so we have. You might want to just keep track of everything on a piece of paper, on a notepad. That might be beneficial in this with pointers. So let's just try to keep track of everything without writing it down. So we have p++, so what would we say? P was pointing to the address, so we have p pointing to the address, which is not this anymore, but it's this. So might as well just copy it, so we have that copied here. Okay, so that's the address of P. So that's the address of P, and P currently points to 1 because it's at index 0. So let's just say that's P, and P is equal to, let's say pointer value P. Okay, I'll just write it down. Pointer value P points to 1. Okay, so now pointer value P points to 1. We have P pointing to the address right there, so we're going to execute that line. Okay, so now we have, after P++, we have this address which we just went over. So we have the address, the new address. Why is that so far forward? It's stuck in error mode because it's like, what are you doing? So that's okay. So so now it's printed over there. So, okay, so this is P. This is P now. And we have, so when the address got incremented, the pointer value also got incremented, of course, because P changed as well. So we have, when the address incremented now, so it wants to give us what the pointer value P is pointing to at this current time. So it should be corresponding to the address. So now we have pointer value P pointing to 2. I should have maybe done those on the same line. That's okay, you guys get the idea. So we have pointer value P pointing to 2. Okay, maybe I could do them on the same line. So we'll have Control X there. I'll just go like that. We'll just do that. Hopefully you guys are understanding and I'm not confusing anyone. So now we're just stepping through it one by one and now keeping track of all the values minus the array, which should stay the same. Okay, so now it's being glitched out. Okay, so now if we say we want the pointer value P++, pointer value P is 2 currently, but we want it with brackets. Okay, I know what happened last time. In the string array, it didn't give us a garbage value. What happened was, I apologize, I think it gave us the next index on the ASCII table. Because we had W, what comes after? A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X. Yeah, it gave us the next. Why is that? Why is that? I'm just trying to think of it. Why is it? Why did it do that? Because we have brackets pointer P. Brackets pointer P. So we have, we're singling it out. We're singling it out. We're singling what pointer P is, rather than taking P as a whole, which is, in this case, it's just the array. Okay, so it's a little tricky to remember. So what's happening here is, what's going to happen on this line, it's going to grab whatever pointer P is, which is 2, and you're going to think it's going to point to the next value, but it is, it's not really doing that. What it's going to do is it's going to take 2 out of the array and store it somewhere else. It's just going to take 2 out of the array and just take the value as it is. It's not going to go for the whole array, if that makes sense. It's just going to take 2 out of the array. Like, imagine a hand going into the array, grabbing 2, or a copy of 2, right? Pulling it out, putting it somewhere else, not even on this page, on another page, placing it there, and just adding 1 to it. That's what it's doing. It's not going to put the hand in the array at 2 and move it over to 3, as what's happening without the bracket. So that's what's happening. Hopefully that finally clears it up. So yeah, that's what happened. Now I was just wondering, well, why did it go to X instead of a, because garbage value usually gives a number. But what happens is it took, in the last example, if you rewind this to the first example, when I said, when we were trying to clear up the confusion of what the brackets pointer P does, is the hand reached into the character array, grabbed capital W, took it out, placed it on another page, added 1 to it. But since it added 1 to it, you have to look on the ASCII character index. If you take W and add 1 to it, you should get X, right? So that's what's happening here. Hopefully that explains everything to you guys. That explains it well. It doesn't confuse anyone. So if we have P, so P is going to give us the address, and did I change? We executed this line. Same address. Yeah, it should be because we just took it out by itself. So the address shouldn't have been modified. Was it OX9996FFFAC4, so that should be the same thing. But the pointer value P did get changed to 3. So pointer value P at this location now is 3. Because we took pointer P out as a whole, we added 1 to it, and we pretty much put it back to where it was. Because when we took the bracket pointer P, again just moving back up to this line for a sec, we reached into the array, we grabbed a clone. Actually, we didn't even grab a clone, we just grabbed the pointer value. We took it out, we added 1 to it, and we put it back in the same spot. So now if we say P is equal to P plus 2, P is equal to P plus 2. On this line. That would mean we have the address, right? So we have the address and the value. We have like multiple printing here, must be a glitch. And they want us to pay like, it's like $5,000 a year for the C line. That's crazy, man. That's crazy talk for something that glitches out, doesn't even work properly. If you want C line for free, by the way, just send them your school ID or your school email. That's how I got it for free. So if you're not in school, I apologize. But if you are, and if you're not in school, you should maybe get in school. If you're not too old, maybe just try to get into the program. So anyway, so you have, if you have the P here, so what is P? So we have the address, it's the address, so let's just copy the address here. Actually, we don't really need to copy, copy it if it's the same thing. Okay, so yeah, so we have the same thing. So once we execute this line, what are we going to have for P? So we said P equals to P plus 2. Excuse me. So what happened to our address? Copy value. So our address changed. So we added a if this is hex code, yeah, it is hex code. It's a hex number. So we added 2 to it. And we got C. So I'm going to need to look at the hex alphabet 1 sec. Let me just pull that up. Apologize for that. Forgot the hex alphabet. So we have hex code. Let's just say hex alphabet. You pull it up. There should be like a certain number of numbers, and then once it gets to 0, it goes 1 to 9. Does it then changes to something? Okay, it's telling me everything else, but I need to know. Okay, here we go. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have capital A, capital B, capital C, capital D, capital E, capital F. That sounds right. So what do we have? We had C. We have lowercase c, so that's not even correct. Okay, so that means that is this hex code? So it's not hex code then. No, it is. Isn't it hex code? Is it octal? It seems like if it was 4, it should have went to 6 anyways. No, sorry. Did we add 1? No, we added 2. Did we say times 2 or plus? No, we said plus 2. So we had AC4. Then it went ACC. So it seems like it didn't really. It kind of went out of exact order, perhaps to a new array, because when we added P to it, it seems like it didn't really stay in the same order that it was. The value of P got changed to 4, so it added 1 to it. What happened there? Sticky keys, okay. Okay, so it added 1 to that. So it seems like it kind of got out of sync. Now if we want pointer P plus plus, then it should add we should get the pointer value incremented by 1 again to 5 at the same memory location that we were at. Sometimes with pointers, like when you modify the addresses, it can start to look a little bit weird, because the compiler can be like, hey, well, why are you like changing the address if we have everything in sync already? And each is spaced out by 4, so how the heck am I supposed to go to the next address if they're spaced out by 4? Like, what the hell do you want me to do? Pretty much that's maybe why it gave us that value, and it might have got confused. So it decided to, okay, well, we'll just increment it as well. So that can happen here and there. I feel like I've seen that a little bit, like with the memory values, like if you're just kind of changing them not in the right order. Like if that was a 2-byte value that we, for our type, then that would have made more sense, like as we saw. Perhaps if we added it 4 onto that, it would have been in more sync with the bytes to the correct array index, as they're spaced out by 4, right? As we talked about, because it's an int, so each byte address is spaced out by 4 bytes from the other one. Like we have AC4, AC0 here. We should have AC8 and AC12 for the next ones, right? Or something like that. Maybe for hex, then it'll change to the next letter and a digit, something like that. But I think when we added when we decided to increment it by 2, the compiler got confused. Like, what am I supposed to do? Because the array is only split into 4 bytes. If I only add 2, what am I supposed to do? So it just kind of gave us something random. That might be right. So now when we added the pointer value p++, it just took the value that it had given us last time and just added 1 to it. And I think the same address was given to us. What did I do? Apologize. So let me just paste that here. So it gave us the same address that we had last time. And all it did was just increment the value, because we said, okay, well, reach into the array, grab the pointer value p, take it out for a sec, increment it by 1, put it back into the same memory location that it was at, right? So that's pretty much what happened. So hopefully you guys understand. We'll be working with some more examples. Hopefully I can clear some more stuff up. If I confused you guys too much, hopefully I didn't. So hopefully with the testing and with the debugging and the testing to see the memory locations and stuff, you guys are able to kind of understand what's happening. Hopefully you guys are learning more about the pointer value p and p, the difference between them, how the brackets are working with it and without. And in the previous example, it actually it took p out, it added 1 to it, added 1 to p as it was, so it took w, added 1 to p, so we took w out, we added 1 to w, which on the ASCII table, 1 plus w should equal x, and then it took x and put it back in the array. So that's what happened. So hopefully that clears it up with you guys. Apologize for that. So in the next example, I think we're done with character pointers here at this point, and string pointers, so we'll move to file operations. So files, storing data in a file, file handling, so we're gonna need pointers for that, so we need to create a file pointer. So we might have to do some notes for this, because there's different types, like there's different types of modes to work with files. Like there's like read mode, write mode, and append mode. So we may have to do some notes for that, and then we have like 1, 2, 3, maybe even 4, 5 examples to do. So we might be splitting those up into 5 different videos, or 2 different videos, or something like that. Maybe 2 or 3. So it's either 2, 3, or 5 videos. Hopefully, you know, that's how it might be. Hopefully, if they're long, it might be 5 videos. Then after that, we've already done command line arguments. We don't really need to do that. We might do a little bit more. What's most important is structures. Structures with pointers. That'll be important, type, def, and union. And then we might have dynamic memory allocation, like malloc and all that stuff. Does that even use malloc? Okay, we do. So we might have a function, we might have a code from that from another book, so we're looking at 5 to 9 more videos for the series, maybe 10. And the series will probably be over. Maybe we could do some more struct videos, something like that. So it's not, the series isn't going to be too long, because we're going to be moving on to Linux. Actually, pretty much already right now. We'll be moving on to, what else are we moving on to? C# and Python. Not right away, that'll be probably, I'm going to say pretty, like, within the next, pretty soon. Definitely, like, maybe within the next few months, for sure. I'm trying to get there sooner. So hopefully we can get there sooner. And if you guys want to see more programming videos, you can subscribe to the channel, and I'll see you guys next time. Take care.